Okay, so what you want to do, looking at this red equation, I kind of already gave you the answer, so let me take this off. So when you see this, this is an identity. You need to determine if this is tangent sum or is this tangent difference. If it's tangent sum, that means that alpha is 20 and beta is 25. So you're going to take the tangent of 20 plus 25. Or it would be tangent of 20 minus 25.
I figure it's the sum because there's a plus sign.
Exactly. So when you look at your identity on your paper, notice that for the tangent sum identity, everyone see that on your purple sheet? It's on the back side, not on the main side, on the other side. So for tangent sum, under where it says sum and difference, tangent sum has tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Do you all see that on your paper? So that tells me that this is an example of tangent sum. And because it's tangent sum, I'm taking the tangent of 20 plus 25, which is 45 degrees. And you should know what the tangent of 45 is. So what is the tangent of 45 degrees? 1. That would be your final answer.
I forget how. You might need to see it again. How is it 1?
We're going to start working with...
Well, did you do that whole thing?
Right. So draw a line. And we're going to start 7.6, which is double and half angle. So double and half angle. So that's what we're starting today. Okay, so today we're actually going to only do double angle. We're not doing half angle. So the way your identity paper is set up is it goes after sum and difference. It talks about double angle. So let's go ahead and do example 1. This is example 1.
Why is there an A there instead of a beta?
So you can use any variable. So this says 2 alpha, but this could be 2x. It could say 2 theta. It could be any variable.
Okay. It doesn't have to be a variable.
Has to be some variable, though, but it could be any variable.
Not just a symbol.
Right. So given this, we're going to find 3 things. The first thing we need to find is the cosine of x. And then we need to find the sine of 2x, which means because that's being multiplied by 2, that means I'm looking for a sine double angle. And then I'm also going to find the cosine double angle. So I'll give you a second to copy this down. And this part here is really important. We'll talk about that. I want to point out, notice that there are 3 different equations that you can use for cosine double angle. Do you see that on your purple paper? There's 3 choices. For sine double angle, it's only 1, and for tangent double angle, it's only 1. All 3 of these will give you the same answer. So they all give you the same answer. Okay, so let's start off by finding the cosine of x. So in order to find cosine, we're going to use the Pythagorean Theorem. So let's start off with finding cosine. So I'm going to call this part A, this is part B, and this is part C. Okay, So if I want to find the sine double angle, in order to find sine double angle, I need to know sine and cosine. They only gave me sine. So let's go ahead and find
Where do we get
the sine of x. So to find the sine of x, we're going to use the Pythagorean Theorem. Now sine equals opposite over hypotenuse.
Excuse me?
Wait, 1 second. 1 second.
Okay.
So opposite over hypotenuse. So when I'm doing the Pythagorean Theorem, what is C going to be? 5. And then the opposite, we'll call that 4. And you're going to solve for the adjacent side. So go ahead and solve that for adjacent. So for part A, we have to find the cosine. In order to find cosine, we need to know adjacent over hypotenuse. So go ahead, take a moment and solve this for adjacent. So 5 squared is 25. 4 squared is 16, and that's plus adjacent squared. Subtract 16. 9 equals b squared. Take the square root. And 3 equals adjacent. So the adjacent side of this right triangle is 3.
But for the sine there, the opposite's 4 and the hypotenuse is 5. So you place the 4 in the A. Oh, A!
Yeah, we could switch that. Yeah. So 3 is the adjacent side. So that means that the cosine equals 3/5. So that's part A. But we have a problem here. This right here is really important. So let's look at this. What does this mean? X is between pi over 2 and pi. What quadrant is that? What quadrant is between 90 and 180? What quadrant is that again? 2. So this is important because we're in quadrant 2. And in quadrant 2, is cosine positive or negative in quadrant 2? It's negative. So we need to add that negative in front of that 3/5. Because in quadrant 2, sine is positive, but cosine is negative. So when we're asked to find the cosine of x, we have to put negative 3 over 5. That's why that's why they gave us this restriction. Okay, so now we're ready to find the sine of 2x. So for sine of 2x, there's only one formula. And that formula, sine double angle. For sine double angle, it says you have to take 2 times the sine times the cosine.
And the sine is, we figured it out.
So the sine was given to us. Sine is 4 over 5.
Okay.
And the cosine is negative 3 over 5. So go ahead and multiply straight across.
Is the 2 out there? Do you have to multiply by the 2 involved as well?
Yes. And if you want, you could put that 2 over 1. So you're going to take 2 times 4 times negative 3. That's your numerator. And that's over 1 times 5 times 5.
Okay, just 20 something.
When we multiply straight across, we get that my sine double angle is equal to negative 24 over 25. So now we're ready to find the cosine double angle. So there are 3 different choices that we can use, but if you know sine and cosine, then I'm going to use the first one because the first one is a little easier to work with. So because I know sine and cosine, I'm using this one. Now I want to make sure you understand that all 3 will give you the same answer. But because I know sine and cosine, I might as well use that first one. So let's go ahead and find the cosine double angle. Let me go ahead and make myself some space. So for part C, cosine of 2x is going to equal, wait, that's a little messy. All right, so to find my cosine double angle, I'm going to take the cosine squared minus my sine ratio squared. So cosine squared would be -3/5, and sine squared is +4/5. So we're going to do order of operations.
It's kind of hard to square a fraction.
So you square the numerator and the denominator. So -3 squared is 9 over 5 squared, which is 25, minus 4 squared, which is 16, over 5 squared, which is 25. If you take 9 minus 16, you get -7 over 25. So now you have found all three.
Oh.
And that is that. So for our second question, this is what they gave us. They gave us cosine this time. This is the quadrant. So this here represents the quadrant. What quadrant are we in? It says between pi and 3 pi over 2. So what quadrant is pi to 3 pi over 2? 3. So that's important. So they gave us this. They told us we're in quadrant 3, and they're asking us to find 3 things. So I'll give you a moment to copy it down, and then we'll work through it together. What I want to make sure you understand is that if I want to find sine double angle, what do I need to know? I need to know sine and cosine. Do I know sine and cosine? Did they tell us sine and cosine? No, they only gave us cosine. So I need to start by finding sine. That's my first step. Even though it didn't ask us to find the sine, I need to know sine in order to answer this first question. So let's go ahead and find the sine of theta. So we're going to do the Pythagorean Theorem. We're going to find sine using the Pythagorean Theorem. So cosine is equal to adjacent over hypotenuse. So 13 squared equals -5 squared plus b squared. Go ahead and solve that and find b. We have 169 equals 25 plus b squared. Subtract 25 from 169, that's 144.
And then square root that to be 12.
And then you square root that and you get 12. So 12 equals b squared. So the sine is equal to 12 over 13. Now, is that going to be a positive or a negative? And we're in quadrant 3. So in quadrant 3, is sine positive or negative? So we have to put that negative with that. Now that we know sine, we can find our sine double angle. So let's go ahead and find sine of 2 theta. Sine of 2 theta is going to equal 2 times the sine, which is -12 over 13, times the cosine, which is -5 over 13. Go ahead and multiply straight across. But don't worry about reducing. Okay, so when I multiply it straight across, I would get that my sine double angle is equal to 120. And it's positive because I'm multiplying 2 negatives over 169. That would be my answer for my sine double angle. Any questions about that?
I'm going to see if I can do this.
All right, so now let's move on to the cosine double angle.
Oh, actually, I think it does. But just to be sure.
So let's do the cosine double angle now. So for cosine double angle, again, we have 3 choices. And again, if I know sine and cosine, I always use the first one. to me, that one is just easier to work with. So I'm going to use that first one. So that first one says
Cosine squared.
cosine squared minus sine squared. So cosine is negative 5 over 13. And sine is negative 12 over 13. Okay, so let's go ahead and do that. So when I square this fraction, top and bottom, I get 25 over 169 minus 144 over 169. Go ahead and take 144 minus 25, and then you know your answer is negative. So you should get negative 119 over 169. So that would be your cosine double angle. Let me make sure. Yep, that's right. Okay, last but not least is tangent. So when we look at the tangent double angle, tangent uses tangent. So I have to know what the tangent is. Now, to find tangent, you would take your sine and divide it by cosine. But I know that tangent is equal to opposite over adjacent. Opposite is 12 and adjacent is 5. So tangent of theta, my tangent is 12 over 5. Now, is that positive or negative? In quadrant 3, is tangent positive or negative? Positive. So we're going to keep that positive. So now we're ready to do this identity. This is the identity we're using. So does everyone see that on their purple sheet? The tangent? Okay, so let's go ahead and do it. So for tangent, it says there's a lot of math in tangent because we have a fraction. So we're going to take 2 times the tangent. So 2 times 12 over 5. And that's all over 1 minus tangent squared. So 1 minus tangent squared.
12 over 5 squared.
Yep. So we got a lot of math to do. This is our last question, though. We'll be finished. So let's go ahead and do the numerator first.
That's fair. It seems to be the easiest.
So my numerator is 24 over 5. Does everyone see how I got 24 over 5? So I just multiplied 2 times 12, because that 2 has an imaginary 1 under it. So 2 times 12 over 1 times 5. And that's all over 1 minus 12 over 5 squared, which is 144 over 25. All right, hopefully you guys understand why I'm doing this next step. So what I'm going to do is I have the 24 over 5, and that's divided by that 1, which is really 25 over 25 minus 144 over 25. Do you understand why I had to write that as 25 over 25? Because I can't subtract unless I have a common denominator. So instead of 1, 25 over 25 is the same as 1. So now we can go ahead and finish this out. So I have 24 over 5 divided by, what's 25 minus 144? Negative 119.
24 over 25 over that 119.
So how do you divide two fractions? Keep, change, flip. So 24 over 5 times 25 over negative 119. Okay. So just so you guys know, I don't know if you guys know this or not, because but do you know that you can cross reduce? Because if you take 24 times 25 without a calculator, that's a lot, right? But we can make this easier by reducing.
The 1 over the 5.
These two can be divided by 5. So if I divide those two numbers by 5, this changes to a 5 and this changes to a 1. So your final answer is going to be 24 over 5 over 1 times negative 19.
That doesn't exactly make.
So we have
24
24 times 5, which I feel like we've done already, is 120. And that's over 119. And you can put that negative anywhere in the fraction. So you answered all 4 questions. So given the information, so today we just practiced with double angle. Tomorrow we're going to solve equations that involve double angles. Everyone take out homework 11. Homework 11 is due tomorrow. If you're finished with homework 11, you can go ahead and start homework 12. You can't do numbers 1 and 2, but you can start at number 3, 4, and 5.